I thought I would tell a story from when I was a young scientist. I'm no longer a young scientist. That may be obvious. I've been in this business. My first research lab experience was actually in 1967. So I've been doing this for a long time. When I was in my young 30s, I was trying to figure out if I would be a good scientist, picking it as a career and deciding what did it mean to me, what did it mean for my life to become a scientist and so forth. So I had just finished my training, and I had just set up my own independent laboratory for the very first time, a very small scale type operation, as most young scientists are in their young 30s. And I was at that time studying a big question. Even then I understood it was important to ask a big question. So I was trying to understand how the genetics of our bodies control our immune system. How does our immune system know what to attack and what to leave alone? And there was already quite a bit of information in the field about how this would occur. Some people had done quite a bit of work in mice, and it was well recognized as that there were fundamental genetic elements that did exert control over the immune system. And so I was working on this in humans. So I was one of the first people to start doing this in people, and had done some experiments with, at that time we would now consider it rudimentary genetics, based on the technologies that have changed, of course. But at the time it was cutting edge. We had developed some very new ways of looking at genes. And I had an insight into how the genes in our body are organized in a way that can address that question. How does the immune system know what to recognize and what to leave alone, what to attack and what to leave alone? So I was working in the lab like this and had a pretty good idea of how things worked. And I read an article. It was a book chapter by a very famous immunologist at the time, a French immunologist, where he was tackling the same question. And he had written a whole book chapter about this, full of diagrams and everything else. And I read this thing and I realized he's got it all wrong. This is complete nonsense. To me, what this did is it made me realize that even as a young scientist, I could make a difference. I could really help advance the field. I can change the way people think about things, even things that are big questions. And I'm not telling this story to diss another scientist, an older scientist. It was obvious to me at the time why he had made the mistake. He was using a framework of thinking about genes and about immunology that was based on an older way that people had done science. And he had not embraced the newer technology, the newer ways that we needed to think about what the data was telling us. So it wasn't a me versus him, or thinking that I knew more than the world or that I was any smarter than anybody else. It was just the recognition that as a young scientist, I could have a perspective and I could make a difference. And I think that's something that has stuck with me even this long. I mean, basically every decade or so, I have changed what I work on in my career, looking for the opportunities to really bring in the newer technology and the newer ways of thinking and advance the field and to tackle new questions. And so even though I've been an immunologist for almost 50 years, it's changed a lot in that time, and I've tried very hard to change with it. In a sense, I started out in basic science, like that example I just told you about, realizing, oh my gosh, I can do this. I can be a scientist. I can make change. Starting out in basic science to where I am now, where I lead these clinical trials. It's been an interesting transition.